Hello everybody, this is Mr. McNair, and this is a short video on solving linear systems by substitution. Before we get into the math portion of everything, I want to relate this to real life. Let's say you go to a fast food place and they tell you that you can get a fish value meal for $5.20. In that value meal, you get a fish, a small fry, and a drink. Now, because America is doing this Go Healthy concept, which we should, um, they might also tell you that you're allowed to substitute a fry and a side salad, meaning that those two things have the same value. Now, when you do a substitution, you replace two things that are of equal value. So instead of the fry, now I can get a side salad. And the cost would still be the same because those are of equal value. All right. Now notice that you can't get both the fry and the side salad. You get one or the other because those are equal to each other. Now, mathematically speaking, I give you this system, this linear system, and I tell you that y equals x plus 1 and 2x plus y equals negative 2. Now, just like before, you have something that's equal to each other. Here, you know that y is the same thing as x plus 1. These are equal to each other. They're worth the same value. All right, so since I know y is the same thing as x plus 1, I could take that x plus 1 and sub it in for the y in the other equation. So here, I can rewrite the second equation as 2x plus y. Now, what's y equal to? It's equal to x plus 1, and that equals negative 2. So all I did was substitute in x plus 1 for y. Now, if you notice, I do have these parentheses here. And the reason why we put parentheses there is sometimes when you do substitution, you might have to distribute. Now, is there anything to distribute in this problem? There's no number directly out front, so this one doesn't have anything to distribute. So we actually don't need the parentheses there. From this point, we go ahead and we solve this problem just like we would solve any linear equation. Here, combine like terms, 2x plus x equals 3x. Bring down our plus 1 equals negative 2. How do you get x by itself from there? Well, we would have to subtract 1 first. Whatever you do one side, do to the other, leaving you with 3x on the left and negative 3 on the right. To isolate x from there, we would divide by 3. So we get x equals negative 1. Now that you know that x is negative 1, we could take this value and we could plug it in to find the y up here. All right, so we know that y is the same thing as x plus 1. Well, you know that x, since we did this problem already, or solved for x already, we know that x is negative 1. So y equals x plus 1. And we know x is negative 1. So what's negative 1 plus 1? It's 0. So our answer is a composite of 0 for y and negative 1 for x. Now this is the same answer that you would have gotten if you had graphed it. And you always want to write your answer as an ordered pair. And remember, ordered pairs always go x first, y second. All right, so that's our answer. Every Y student should check, plug it in, make sure that your values come out correct. All right, this problem, similar again. This time we have 2x plus y, or 2x plus 3y equals 31, and y equals x plus 7. So again, we know that x plus 7 is the same thing as y. Those two values are equal to each other. So I could take this x plus 7 and do what with it? Plug it in for the y up top. So I'm just going to completely rewrite my first equation. 2x plus 3y. And what is y? Y is x plus 7. And that has to equal 31. Again, we put parentheses around this x plus 7 just in case we had something that we needed to distribute. Do we here? Yeah, we have this 3 on the outside. So let's go ahead and distribute the 3 into the parentheses. I'm going to drop down the 2x. 3 times x is 3x. 3 times 7 is positive 21. And then I'm going to drop down my 31 on the right. Combine your like terms. 2x plus 3x equals 5x. So we have 5x plus 21 equals 31. To solve for x, we would subtract 21 from both sides. So these cancel out on the left, leaving you with 5x equals 10. Now to solve for x, we divide by 5 on both sides, and we get x equals 2. All right. Now, once again, our answer should be an ordered pair, an x and a y. So we're going to use this 2 to find out what y is. So since we know that y is x plus 7, and now that we know x has a value of 2, we just sub that in. And what's 2 plus 7? 2 plus 7 is 9. Good. All right, so our answer is 2 for the x and 9 for the y. And every y student would plug those values in to their right place to check their answer. All right, let's do another one. This one is a little bit different because it's not solved. It's not solved for y this time. This time we know that the value of x is the same thing as 4y plus 11. But you're not going to do really anything different. Only thing that is really different is that you're subbing in for x instead of y. So we know that x has the value of 4y plus 11. Those are the same. So we're going to take that 4y plus 11 and sub it in for x. So I'm going to rewrite this top equation. 4y minus 5x. And what is x? X is 4y plus 11. And that equals 9. Once again, you're going to take this and you're going to solve it just like you solve any linear equation. Be careful here, though, because this parentheses, like we said before, is necessary when you have something to distribute. What are we distributing in this problem? Be careful, it's not 5, it's negative 5. So we have 4y. Negative 5 times 4y is negative 20y. Negative 5 times 11 is negative 55. And that equals 9. We're going to go ahead and simplify by combining like terms. 4y minus 20y is negative 16y minus 55 equals 9. We'll add 55 to both sides here. So here, the negative 55 and positive 55 cancel out, leaving you with negative 16y equals 64. Now that you know negative 16y equals 64, divide by negative 16 on both sides, and you get y equals negative 4. Once again, you need to make sure that you solve for both variables, the x and the y. So now we could take that y equals negative 4 and sub it in to find x. So since x equals 4y plus 11, and we know that y is negative 4, we just simplify and solve. So 4 times negative 4 is negative 16. Negative 16 plus 11 is negative 5. So our answer, negative 5 for x, negative 4 for y. And every y student will check your answer after that. All right, last problem. This one, very similar to the previous. Again, we know that x is the same thing this time as negative 2y plus 4. Those are the same value. So again, we're going to take this value, negative 2y plus 4, and sub it in for the x down here. So we have y minus x. And what is x? Negative 2y plus 4. And that has to equal negative 7. Now, is there anything that we need to distribute on this problem? Yes. The number out in front of the parentheses this time is a negative 1. So that's the number that you need to distribute. So on the left, we drop down our y. Negative 1 times negative 2y is positive 2y. Negative 1 times 4 is negative 4. And that equals negative 7. Simplify by combining like terms, we get 3y minus 4 equals negative 7. Add 4 to both sides to solve for y. So we get 3y equals negative 3. Divide by 3 on both sides, we get y equals -1. Now that you know that y is -1, you take that value and you plug it in to find the x. So x equals -2y plus 4, and we know that y is -1. So we simplify. -2 times -1 is +2, and 2 plus 4 is 6. So our answer, 6 for x, -1 for y. All right. I hope this helps. If you needed to review this anymore, make sure that you go back, rewind, pause, do what you need to get an understanding of this. All right. I hope everybody has a great day, and Happy New Year to you all.